a push-bot program for the Tetrix style competition robot. The first thing we need to do, as always, is open our schematic editor to set up our components on our robot. That way, when we go to program, our program knows exactly what is connected to our robot. This also allows us to test our robot setup, our hardware, once our robot is completely built. So it's going to start us out on EV3. I'm going to go ahead and switch this to NXT since that's the brick that we're using. In sensor port 1, I need to have a HT-DC motor controller. And I'm going to put 2 Tetrix DC motors in my ports. And for Tetrix DC motor 1, I'm going to rename that one, and I'm going to rename that to left foot motor. And then my Tetrix DC motor 2 is going to be right foot motor. And on this one, I want to remember to click the reverse checkbox to reverse that motor. We're also going to be using some servos. So I'm going to daisy chain a servo controller, HT servo controller, to my HT DC motor controller. And I'm going to go ahead and put 2 servos on. So one in servo port 1, and I'm using a Tetrix 180-degree servo. And sensor port 2, so same thing, Tetrix 180-degree servo. So I'm going to rename the Tetrix 180-degree servo, the first one, to left-hand servo. And servo number 2, I'm going to name right-hand servo. So as far as sensors, I'm going to go ahead and put my light sensor on sensor port 2, my ultrasonic on sensor port 3, and my touch sensor on sensor port 4. And then we're also using our LEGO NXT motors. So I'm going to go ahead on motor port A and put NXT motor. I'm going to also put one in port B. And for NXT motor 1, I'm going to name this left arm motor. And for NXT motor 2, I'm going to name this one right arm motor. So then this is what my whole schematic editor looks like with 2 NXT motors. I have all the sensors, my 2 DC motors, and my 2 servo motors. So I'm going to go ahead and save and close my schematic editor so that way I can start my program. So there's 2 different types of programs that we're going to do. This first one is an autonomous program, and it's a program that runs the robot on its own. It is not user operated. The second program we're looking at is teleop, and teleop is teleoperated, meaning the user is driving the robot with some sort of control. So in our case, with our controllers. But we're going to start first with the autonomous program, which is the program that we have been doing all along. So I'm going to click on the programs folder and new VI, so meaning virtual instrument. And I want VI for NXT. And I want to name this one pushbot. And I'm going to name this pushbot autonomous. Like I said, we're going to have 2 different types of programs. Okay, so I named this pushbot autonomous, and autonomous just means the robot runs on its own, so I'm going to go ahead and create that program. And I want to make sure that I am programming on my block diagram. So the first thing that I want to do is to create my code. And my code is going to be in different frames for this program. And the frames allow me to run my program in sort of a parallel execution, which means it's running all of the frame and then doing the next frame. So kind of like film strips that you would see for movies, and it's similar to the case structure, but instead of having to flip through the case structure and have something beside the cases, the frames just go in order. So I'm going to go ahead and pull up my functions palette by right-clicking, and I'm going to go to Programming, Structures, and in this case I want a flat sequence because it's going to be a sequence of frames that go in order. So here's my first frame, and the first thing I want to do is have my servos start out by being closed for my arm. So I'm going to go ahead and under Mindstorm Robotics, Input Output, Advanced Motors, I'm going to go ahead and put down a move servos. So I need to tell the program which servos I'm using, so I'm going to go ahead and right click, create constant to initialize my servos. And in this case I have two servos that are going to be working together. So I'm going to go ahead and put two servos on and have the red one be my left hand servo. So be very careful about which one you select. And my blue one is going to be my right hand servo. And these two, even though they're working together, they're facing opposite directions. So I'm going to create a constant for my red servo, my left hand servo, and put that at 0, which is all the way in one direction. And my second one, my blue one, is going to be at 255, which would be the other direction, which really is going to close my servo, close my arm, since the two servos are faced in opposite direction. So I'm going to go ahead and put some text here to let me know what it needs to do with this part of the program. So if you double click, it will let you put a text label, and I'm going to put servo closed, servo arm closed. So I know when I go back to look at my program that that's what it's doing at this point. The next thing I want to do is to have my NXT motors lift up my arm. So I'm going to go to Mindstorm Robotics, Input Output, and down to Complete, because I want to go to this LEGO Motors menu. And in the LEGO Motors menu, I want to use motor reverse. And once again, I need to tell my program which motor ports my LEGO NXT motors are in. So I'm going to right click the top, create a constant, and in this case they are in ports A and B, and they're working together. And I'm going to give this a power of 100, which is actually going to make it go backwards. So I don't need to put negative 100 because this function block already is making my LEGO NXT motors go backwards. And this is going to lift my arm. So I'm going to go ahead and put a label down here by double clicking and put lift arm. It's a really good habit to have when you're programming, to give yourself notes along the way, so that way anybody can look at the program, and even yourself look at the program and know exactly what's going on. So like always, you need to connect your NXT wire for order. And then the next thing I want to do is to have my NXT motor in port A count until it reaches a certain value for the lift arm. So I'm going to go once again into my LEGO Mindstorm, or my Mindstorm Robotics Input Output, and I want to go to So I'm going to go to Input Output, Complete, And in this case, I want to go for a weight. So under weights, I'm going to go all the way down until I see the LEGO motor, which right here is weight for rotation. So I'm going to put that weight for rotation down. And what that does is it counts the number of times your LEGO motor makes a full rotation, so spins, and once it reaches a certain value, then it will move on to the next thing. And then the next thing, in this case, we're going to have it break. So I need to, once again, tell my program which port it's in. So I'm going to create a constant. And this is just going to take port A. So just one of the LEGO motors, NXT motors, is needed to keep count of the rotations. And I'm going to create a constant for the position change, so the rotations. And I'm going to put this as -500. So really it's going to count the number of times that my motor goes, and in this case, since it's going backwards, I do need to do -500. And once it reaches the -500, it's going to go ahead and move on to the next block. And so in this case, I want the next block to be my break. So I'm going to go back to my functions palette, input output, complete, and I want LEGO motors because I want motor break. And that motor is going to be breaking both motors A and B, so I'm going to go ahead and just connect that back to the motor ports A and B. And connecting my NXT wire to each block as we go through. So this program, once again, is going to close my servo arm, so the gripper part. It's going to lift my arm, and it's going to break once it is all the way lifted. And of course, these values we can adjust once we run the program. So the next thing I want to do is add a frame after this frame to run next. So if you right click on the frame border, the flat sequence structure border, I can do add frame after, which is going to give me another frame. I'm going to drag this frame out by using the blue boxes to make it bigger. So in this frame, we want to drive the robot forwards. So we want to go ahead and drive the robot a fixed distance. So to be able to run our motors for only a certain amount of time, I'm going to go ahead and use a for loop. So under Programming and Structures, I'm going to go to for loop. And inside that for loop, I'm going to go ahead and put my DC motors. So I'm going to put input output, move motors. And I need to create a constant. And I'm going to choose 2 motors. So I'm going to click the down arrow. And my red one is going to be my left foot motor. And my blue one is going to be my right foot motor. Now, if I leave this initialization box inside the for loop, nothing else can access it. So I'm going to go ahead and click and drag my initialization box outside my loops and reconnect my wire. And I'm also going to go ahead and do that with my left hand and right hand servo. So that way I can access those. And once again, my wire broke, so I'm going to reconnect my wire. And it looks like my wire also broke for the 255, so I'm going to reconnect that and delete any extra broken wires I have. So you can either click on it and press delete, or Control B also gets rid of all your broken wires. So I only want my motors to run for a certain amount of time. So I'm going to go ahead and on my loop count, I'm going to create a constant, and I'm going to start with 150. We can go ahead and adjust this later to see exactly how far that gets us. But I do need to give my motors a speed. So in this case, for my speed, I want to go ahead and give that a constant, so I'm going to right click and create constant. And I'm going to give that constant 100 power. Make sure to connect your blue wire, your blue motor, to the red so that they're sharing that same constant. And make sure to connect your NXT wire to each block. So that's going to run my motors for this loop to go 150 times. And I'm going to go ahead and put down a label down at the bottom by double clicking. And I'm going to call this drive forward. So after it drives forward for that 100, I need to make sure that I brake my motors. So I'm going to go ahead and put in, for my input-output, I'm going to put stop motor on the outside of my for loop. And I need to go ahead and share the same motors that I had before. So I'm going to connect to my initialization box. And remember, if your node ever looks empty like this, right click on it, go to tunnel mode, and go to last value to fix that broken wire. Okay, make sure you save every so often. And then the next thing I want to do is create another frame because I want the robot to drive forward until it detects a white tape line. So I'm going to right click the frame and add a frame after, and I'm going to make that frame bigger. So inside this frame, I want my DC motors to drive forward until it sees the line. So I'm going to go ahead and put in, once again, my move motors block. And it's going to share the same initialization. I'm going to connect my NXT wire. And I want the robot to start driving forward and then check for a light value. So I'm going to go ahead and give my DC motors a constant power. And I'm going to make my power 100 again and connect my right foot motor power line to that 100 also. So to continuously check for the line, for the white line, I need to use a while loop. So I'm going to go to Programming, Structures, and While Loop. And inside that while loop, I need to go ahead and put my light sensor. So under Input-Output, Sensor. And I need to have something to compare to be able to stop the loop. So I'm going to go to Programming and Comparison, and I'm going to put less than or equal to, so less or equal to block. So I'm going to connect my NXT wire, my light sensor value, so I need to change my touch sensor to a light sensor, so I'm going to go down to Pressed, Read NXT light, and I want to make sure my LED is on. And then that light sensor value, which is a scaled value, so it gives me a number, is going to go into my X part of my less or equal to block. And I'm going to have it compare to a value, and I'm going to create a constant of 50. So it's going to compare to 50 as far as darkness. And then the result of that is X less than or equal to Y. That's going to go into my loop condition, which is going to stop my while loop. I'm going to give myself a label here that is called drive forward to line. That's what this frame is doing. It's driving forward until it sees a white line. And then after the while loop, I need to go ahead and break my motors. So I'm going to go to input output and stop motors. That needs to be the same motors that I used before. So I'm going to connect to my power line. And I'm going to connect my NXT wire to make sure that it's going in the order that we want it to go into. So the last step in our autonomous routine is to open the hand, open the arm. So I'm going to go ahead and create a new frame. So right click on the frame and add frame over and make this frame larger. And I want to take my servos and change their position to open the hand. So I'm going to go ahead and put in input output and motors, so advanced motors, and move servos. And those servos are the same servos that I used before. So you can either connect back to the beginning, or I'm going to recreate their constant and just re-choose left hand servo and right hand servo. And before I had the red servo being at 0, so this time I want to create a constant of 255. And then the right hand servo, so the blue servo, I'm going to create a constant of 0. So I'm going to connect my NXT wire, and I'm going to give this one a label. This one is called open hand. So the very last thing that the robot's going to do in my autonomous program is going to open its hand. I want to make sure that in the end that my robot is not moving. So I'm going to go ahead and put one last lock. And I'm going to put input output stop motors, just to make sure that my robot is not running away. So I'm going to connect my power motor, and now I can brake. So now we can deploy this program and test it, because we may have to change the light sensor value, what it's comparing to, we may have to change the servo values, and we may have to change the for loop. So the for loop that was back here, that was determining how long our motors went. So we may have to change this number to make it either go further or shorter.